Hello again. My name is Dr. Jawad Alzeer. I would like to continue talking about the concept of entropy and try to see how we can find a good explanation to simplify this concept, particularly for students whom they study chemistry or physics. So previously we talked about the general concept, what is known in the textbook, and today we would like to go a little bit deeper to understand this concept of entropy in the context of chemical reaction. And I think this is confusion start because we start moving from the concept of disorder to something which has to do with the energy. And that's why here we have to include the well-known formula which is used for determining the directionality of the reaction, which is called Gibbs free energy. And now we want to know exactly how this concept, disorder, can influence the directionality of reaction. Now, Gibbs free energy is trying to give a sort of answer in this regard. It basically represents the changes in enthalpy and entropy. So enthalpy has to do with bond breaking and bond forming. And of course, still the concept of entropy has to do with this general explanation, which is the disorder. Now, how to understand this disorder in the context of chemical reaction? It's complicated, but usually they try to simplify it in a way that by looking at the number of moles in the reactant and the number of moles in the product. If the number of moles in the product is increased, it means reactants, molecules, by default, they dissociate into smaller molecules. And because it dissociated into smaller molecules, so we increase the possibility of arrangements of those molecules. So we increase the microstates and ultimately increase the disorder. And that's why, in this context, entropy would be considered positive. In general, when delta G is negative, it means that this reaction is spontaneous. It means it will release energy. It is also called exotherm. And because it is spontaneous, probably it just needs a little catalyst to initiate the reaction, but overall, in the end of the reaction, energy or heat will be released. And usually this can be detected in form of temperature. So one will notice that temperatures increase. Now the reverse reaction, when we try to associate molecules with each other, so now we build order. Because we are building order, we are going against entropy. And in this case, entropy is negative. And because entropy is negative, so this reaction, of course, is a challenge. It's not spontaneous, it needs to be catalyzed, and it required energy. And therefore, the overall delta G is positive, which means that this reaction is not spontaneous and it is endotherm. Now, still, to understand this concept in the context of pure entropy, it is important to look at the factor temperature. Now, temperature's effect in the context of entropy, while we are using this Gibbs free energy equation, is notable. And for me, I think it is better to understand the impact of entropy change on the reaction spontaneity when temperature is fixed or it is at constant temperature. And by fixing temperature, then exactly we can understand the changes of entropy and really how entropy can influence the directionality of the reaction. And I think we will do it in the next video, and then we will try to explain this in the context of chemical reaction still, but we try to look for a system where temperature is constant all the time. Thank you.